Hello everyone, welcome back to a new video. So in this video, we'll be solving some more questions related to arrays and vectors. So without further ado, let's get started. So the first question that we have here is the missing number. So what does the problem state? So we'll be given integer array nums which will be consisting of integers from the range 0 to n, and we have to find a number from the range 0 to n which is missing in the array. So, as you can see here in the given example, the array consists the numbers from the range 0 to 6, and we have to find the number from the range that is missing in the nums array. So, from the observation, we can observe that the number that is missing from the given array is 3. So, our answer in this case will be 3. So how can we solve this question? So the extreme naive solution to solve this question will be something like, so I'll be searching every element from the range 0 to n in the nums array with the help of linear search, and I'll see whether that element is present in the nums array or not. If the element is present in the nums array, so I'll simply move ahead with the next element. If element is not present in the nums array, so that is our answer, and I'll simply return that element. So as you can see here, the numbers are there between the range 0 to 6. So the first number from the range is 0. So I'll see whether 0 is existing in my array or not. So 0 is already present in the array. So I'll move ahead with the next element. So our next element is 1. So I'll search whether there is 1 present in my nums array or not. So 1 is there in my nums array. So I'll move ahead with the next element. The next element from the range is 2. So I'll search for the 2, and 2 is present in my nums array. So I'll move ahead with the next element. The next element from the range is 3. So I'll search the element 3 in the nums array. So as you can see, while searching, the element 3 is not present in the nums array. So I'll return 3 as my answer. So let's try to see pseudocode for this approach. So we need to iterate over each element from the range 0 to n. So we'll need a for loop which will be iterating over each element from the range 0 to n, and will increment our I. Nextly, we need to find this element in our nums array, and we need to check whether that element is present in the nums array or not. To verify this, I'll need one variable named flag, and initially it will be marked as 0. So we'll iterate from int j equal to 0 till my j is less than n, and I'll increment j. So now I'll check if my nums of j, if it is if it is equal to my element I. If it is equal, then I'll mark my flag variable as 1, and I'll simply break out of the for loop. So after breaking out of the for loop, I'll check if my flag variable, if it is equal to 0, that means the element which we were searching in the nums array is not there. So that element is our answer, and will simply return that element as our answer. And that's it. So we are done with the pseudocode. So let's try to see the time complexity for this approach. So as you can see, we are iterating over the elements from the range 0 to n. So this will take us time complexity of big O of n plus 1, and here in the inner for loop, we are iterating over the array which is consisting of the n elements. So that will be taking us time complexity of big O of n. So the overall complexity will be near about big O of n square in the worst case. But as you can see, it is not possible. So it is the hypothetical case that the time complexity would be the big O of n square. So as you can see, if you are searching for the element 0, so you will simply find element 0 at the first position itself and you will break out of the for loop. So you are not iterating for the next part of the array. For the element 1, you are going till the second last element. For the element 2, you are going till the third element. So every time you are not iterating over the complete array, so the time complexity would be big of n square in the hypothetical conditions. So that was the time complexity. So what is the space complexity? So talking about the space complexity, so we are not consuming any extra space. So my space complexity would be big of 1. So that was the brute force approach for this question. So can we optimize this approach into the better one? So if we can optimize the time complexity that we are using, so we can easily optimize this question into the better one. So let's try to see the better approach for this question. So the better solution for this approach is based on the concept of hashing. So as you can see, we are having a nums array which is consisting of elements within the range 0 to n. So we'll declare an hash array which is of size n plus 1, and I'll iterate over the elements from the nums array, and if the element is present in the nums, so I'll mark the element at the index of the element in my hash array as 1. So let's suppose I'm having an hash array named frequency which is of size n plus 1, and initially all the elements are initialized with the 0. So here it will be index 0, here it will be index 1, here it will be index 2, here it will be index 3, here it will be index 4, here it will be index 5, and here it will be index 6. And all the elements are initially marked as 0. So I'll iterate over the nums array and I'll mark the element at the index of the current element as 1. So here, as you can see, the first element is a 0. So I'll mark the element at index 0 as 1. So here it will be marked as 1. The next element is a 6. So I'll mark it as 1. The next element is 2. So I'll mark it as 1. The next element is 4. So I'll mark it as a 1. So next element is 1. So I'll mark the element at index 1 in my frequency array as 1. The next element is a 5. So I'll mark the element at index 5 in my frequency array as 1. After iterating over the nums array, I'll iterate over the frequency array and I'll check which is the element in my frequency array which is having the value 0. If I'm having the value 0 at ith index, so I'll return I as my answer. So in this case, I'll start iterating in my frequency array. So the element at index 0 is 1, so I'll move ahead. The element at index 1 is 1, so I'll move ahead. The element at index 2 is 1, so I'll move ahead. Now the element at index 3 is 0. It means that the element 3 is not present in my nums array. So I'll simply return 3 as my answer. So in this case, I'll return 3 as my answer. So that was the better approach for this question. So let's try to see pseudocode for this approach. So we'll need an hash array of size n plus 1 named frequency. So frequency of size n plus 1, and initially all the elements are marked as 0. So now I'll iterate over the elements from the nums array. So for int I equals 0, my I is less than n, and I'll increment my I. And now I'll mark the elements index in my frequency array as 1. So frequency of nums of I equals to 1. So after iterating over the nums array, I'll iterate over the each element in the frequency array. So we'll need to iterate over the frequency array. So for int I equals to 0, my I should be less than or equal to n, and I'll increment my I. Now if the element at index I is having the value 0, it means that that element is not present. So I'll check if my frequency of I, if it is equal to 0, that means the element is not present in my nums array, and I'll simply return that element as my answer. So that was the pseudocode for this approach. So let's try to analyze the time and space complexity for this approach. So talking about the time complexity, so this for loop will be taking us big O of n, and the next for loop will be taking us big O of n approximately. So now the overall time complexity would be big O of n plus big O of n. That was the time complexity. So let's talk about the space complexity. So here we are consuming an extra space. We are using the frequency array to store the frequency of elements. So the space complexity would be big O of n. So that was the time and space complexity. So we have improved our time complexity in this approach, but we are consuming some extra space for the hash array. So can we optimize this approach? So let's try to see the optimal solution for this approach. So in the better solution, we improved our time complexity as compared to our brute force, but we are using some extra space in the form of the hash array. So in the optimal approach, we'll try to optimize our space complexity. So the solution for this question in the optimal approach will be using some max. So as you can see, we are having the nums array, which is consisting of an element in the range 0 to n, in which one of the elements will be missing. So let's try to find the sum of the elements from the range 0 to n. So here the array is consisting of elements from the range 0 to 6, and the sum of elements from the range 0 to 6 is nothing but 21. Now let's try to find the sum of the elements from the nums array. So here we are having 0, here we are having 6, here we are having 2, here we are having 4, here we are having 1, here we are having 5. So the sum of the elements from the nums is nothing but 18. Now as you can see, the only element that is missing in the nums array is 3, and the extra element that is present in the range 0 to n from the nums array is 3. So if we try to subtract the sum of the elements from the range 0 to n from the sum that we are having of the numbers from the array nums, will be giving us that missing number. So here as you can see, the sum of the numbers from the range 0 to n is 21, and the sum of the numbers from the nums array is 18. And if you can subtract 21 from 18, you will get 3. So that is the number which is not present in the nums array. So here the number that is making difference in the summation and which is not present in our nums array is 3, and we can easily get the missing number from the range 0 to n that is not present in our nums array. So let's try to see the pseudocode for this. So we have to find the sum of the numbers from the range 0 to n. So that sum we can easily find with the formula S1 equals to n into n plus 1 by 2. So that will be giving us the sum of numbers from the range 0 to n. Now we have to find the sum of numbers from the nums array. So I'll declare a variable s2 and I'll initialize it as 0. Now I need to iterate over the nums array. So for int I equals to 0, I is less than n, and I plus plus, and I'll add the elements into my variable s2. Now finally we need to find the difference between the sum s1 and s2, and the difference which we'll be getting will be our answer, that is the missing number. So I'll simply return S1 minus S2 as my answer. So let's try to analyze the time and space complexity. So as we are iterating over the nums array, so this for loop will be taking us big of n time complexity. So the overall time complexity for this approach will be big of n. What about the space complexity? So as we are not using any extra space, so space complexity for this approach will be big of 1. So as you can see, we are using time complexity of big of n, and we have improved our space complexity as compared to our better approach. So that was the optimal approach to solve this question. So let's try to code this question. So here we need to find the size of the array. So that will be giving us the range from which the number is missing. So I'll take the variable n and I'll store the size of our array into n. Now I need to find the sum of the elements from the range 0 to n. So I'll take a variable s1 and I'll find the sum as n into n plus 1 by 2. So that will be giving us the sum of all elements from the range 0 to n. Now I need to find the sum of the elements from the array num. So I'll declare a variable s2 and then I'll initialize it at 0. Now I'll iterate over the nums array and I'll add every element into s2. So s2 equals to s2 plus nums of I. Finally, I need to find the missing number. So that will be given by the difference between the sum S1 and S2, and that will be our answer. So I'll simply return S1 minus S2 as my answer. So let's try to compile this. So as you can see, it has successfully passed the sample test cases. So let's now try to submit this. So it has successfully passed all the test cases and it is successfully submitted. So that was it for this question. So the next question that we have here is maximum consecutive ones. So what does the problem state? So we are given an integer array which is consisting of zeros and ones, and we need to tell the maximum number of consecutive ones. So as you can see, here are consecutive ones, which is three consecutive ones. Here are consecutive ones, which are two. Here are consecutive ones, which are four. So from all these consecutive ones, as you can see, the maximum number of consecutive ones are four. So we simply return our answer as four. So that was the question. So let's try to solve this question. So if you try to think about the brute force and the better approach for this question, so you will end up wasting your time, as the optimal solution for this question is very straightforward. So as we are given the array which is consisting of zeros and ones, and we need to simply return the maximum number of consecutive ones. So initially the number of consecutive ones will be 0, and I'll maintain a counter to count the number of ones that I'm having. So currently the number of count will also be 0, and I'll start iterating over my array. So my first element is 0, so there is no need to increment our counter and no need to update my max. So we'll move to the next element. So our next element is 1. So we'll update our counter as 1, and we'll update our max as 1, and we'll move to the next element. As the next element is 2, so we'll update our count as 2, and we'll update our max as 2, and we'll move to the next element. Our next element is 1, so we'll update our counter as 3, and we'll update our max as 3. Now the next element is 0, so we'll update our count as 0, and there is no need to update our max, so we'll move to the next element. Our next element is a 0, so there is no need to update the counter, so we'll move to the next element. The next element is 1, so we'll update our counter as 1, and we'll check if my count, if it is greater than max. In this case it is not, so there is no need to update max, so we'll move to the next element. Our next element is 1, so we'll update our counter to 2, and as you can see, as our max element is a 3, which is greater than our count, so there is no need to update our count, so we'll move to the next element. So next element is a 0, so we'll update our count as 0, and we'll move to the next element. Our next element is 1, so we'll update our count as 1, and in this case there is no need to update our max, so we'll move to the next element, which is 1, so we'll update our count as 2, and there is no need to update the max, so we'll move to the next element. So next element is 1, so we'll update our count as 3, and there is no need to update the max, so we'll move to the next element. So the next element is 1, so we'll update our count as 4, and in this case our count is greater than our max, so we'll update our max as 4. And if we move ahead, so we'll move out of the boundary of that, and we'll stop iterating. And as you can see, in the max we have got our answer, which is nothing but 4. So our answer is 4, that is the maximum number of consecutive ones from our array. So that was the optimal solution for this question. So let's try to see pseudocode for this. So I'll need a variable count which will be initially 0, and I'll need a variable max which will be initially 0. Now I need to iterate over my array. So in I equals to 0 till my I is less than my size of the array, and I'll keep incrementing my I. Now I'll check if my current element is 0 or 1. If my current element, if it is equals to 1, then I'll simply increment my count. And if it is equal to 0, then I'll reinitialize my count to 0. So after updating the count, I'll update my maximum variable. So the maximum will be equal to max of maximum and count. So at any point, my maximum will be containing the max value between my count and maximum. So at the end, we'll be having our answer in our maximum. So we'll simply return the maximum as our answer. So let's try to see time complexity and the space complexity for this approach. So we are simply iterating over our array. So this will be taking us the big O of n time complexity, and we are not using any extra space. So our space complexity will be big O of 1. So that was it about the optimal approach for this question. So let's try to code this question. So we'll need a variable count, which will be initially 0, and variable maximum, which will be initially 0. So we'll simply iterate over our nums array. So I equal to 0, I less than nums dot size, and I plus plus. If my current element, if it is equals to 1, then I'll increment my count, and if it is not equals to 1, so I'll initialize my count to 0. So after updating the count, I'll update my maximum as the max value between the maximum and count. So after iterating over the array, our maximum will be containing the maximum value of consecutive one. So we'll simply return the maximum as our answer. So let's try to run this on the sample test cases. So as you can see, it has successfully passed all the sample test cases. So let's now try submitting this. It is successfully submitted, and indeed we have solved this question.